Hello everyone. My name is Amparo López and I am full professor at Universitat Politécnica de Valencia in the Department of Hydraulic and Environmental Engineering. Today we will be speaking about the control of the operating point of our hydraulic pumps in terms of speed control. When we finish, we will be able to understand the need of regulation, particularly for an operation point in a system to give a particular water distribution network flow and pressure in a particular point, and to understand the control of this operating point in terms of controlling the speed of the pump. So we will be speaking about the need of regulation in hydraulic pumps, the regulation by controlling the pump curve, and the regulation performance, particularly with speed control, to finally conclude. So first of all, we will be thinking, why do we need regulation in hydraulic pumps? Because pumps are installed in a particular facility to give energy in terms of flow and pressure. To do so, pumps absorb power. In this case, they absorb power for an engine in terms of absorbed power. So when we need a particular point with a particular flow and a particular head, we need to intersect these both curves in the operating point. So what happens is that this particular point can be achieved by changing either the curve of the facility in yellow color with valves or with several pipes and so, or changing the red curve representing the characteristics curve of the pump. So today we will be speaking how to change this red characteristic curve. We must remember that this changing can be done by modifying the characteristics of the pump. But several times this is not easier. We cannot change the rotor of the pump, we cannot change the pump in the operating mode. So what is easier for us is to change the speed of the impeller to have several characteristics curves. When we do this, we can control the characteristic curve of the pump and then control the operating point of the system. How do we do this? We do this by a frequency converter usually. Frequency converters act over the electric engine by changing the frequency of the wave of electricity. And this is transformed into the speed of the pump. When we have this change of the speed of the pump, then we have a change in the characteristic curve of the pump because we have these affinity laws that explains us how the curve of the pump change. If we consider alpha to the relationship in between the velocity and the nominal velocity, we will be changing the curve of a pump with the expression of this head. So what do? We change the curve of the pump to adapt without moving the resistance curve to the operating point that we design. When we do this, we can absolutely adapt to the set point curve. This regulation, by considering change into the speed of the pump, can give us the best performance in any case because we adapt exactly the system to the required flow and the required head. so giving us 100% of performance. This is the best regulation way when we can have this control of the speed in the system. So we spoke about the importance of regulating the hydraulic pump operating point, and in this case, we consider varying the pump's rotational speed to control the characteristic curve of the pump. When we do this, this is the best way to achieve a required flow and pressure because we have the best performance of regulation because we use the minimum energy to go exactly to the set point curve that we need. I hope this was of your interest. Thank you very much indeed.